Many scientific breakthroughs are born here, inside laboratory glassware, the tubes scientists use to hold liquid samples for chemical experiments. They start off as thin glass tubing, stacked by size, weight, length, and diameter. Workers select the correct size for the culture tubes they're making and place them in a magazine. As it spins, it drops a tube into each slot on a cutting bed. Then comes the first cut by gas flame. When the heated tubing contacts the wet steel blade, the thermal shock results in a clean separation of the glass. The tubes get a second thermal shock treatment, which cuts them to length. Then it's onto the glazing bed. A glazing burner shoots out flames at a temperature of 650 degrees Celsius. The heat melts each tube at one end, forming a lip called a glass bead. Just 2 seconds of heat splits the tubes into two. The intense heat forces the glass bottom of each tube to close in on itself. The finishing fire smooths out the closure. Then they shoot a small amount of air into the opened end of the tube, which forms the round curvature on the bottom. Now the tubes head into an annealing oven side by side. They bake for about 15 minutes in 650 degrees Celsius heat. This strengthens the glass so it'll better resist cracking. The heat also sterilizes the tubes. Once they're making pipettes, long tubes that labs use to transfer fluids. A flame heats the glass to form an indentation, which determines the flow rate through the pipette. A wider flame then heats the glass, making it soft and malleable. Large rollers tug at the sides, drawing the soft glass to form the pipette's tip. Now for the other end of the pipette. They cut it to length using thermal shock, and again, a glazing burner forms a glass bead along the rim. A cutting wheel slices through the tip end, creating 2 tubes of identical length. This production line makes vials. These gizmos, called top turrets, feed large glass tubes into a machine. First, a punch-out burner heats the end of the tube to create an opening. Then a steel pin widens the hole on the upper part of the vial. A forming die squeezes the heated glass to sculpt the shoulder, while a steel plug rises from the bottom to open the vial even wider. Then a second forming die shapes the neck. Next, a parting burner splits the vial into 2. A bottom turret plucks the newly created one and draws out the soft glass to lengthen it. Fingers inside the turret prevent the glass from breaking. All that's left now is shaping the bottom of the vial. A burner forms a concave base in less than a second. The vials now slide down to what's called an afterformer machine. Here, suction cups lift and place each vial into metal grooves on a printer bed. It's a basic silkscreen printing process, with a squeegee pushing paint through the screen's holes onto the vial. Grippers now place the vials on a rack headed for the oven, where they'll bake for about 20 minutes. Finally, a robotic arm whisks the finished vials to packaging. From there, it's off to a blood bank, a hospital, or chemistry class.